Today we are going to be looking at valence electrons and what they mean. Now, I know the other day we took our periodic table and we marked it up. And we marked it up real good, and it has a ton of information on it. And we've already sort of talked about these numbers representing valence electrons. Well, today we're going to dig deeper into a valence electron and what that really means. All right, so you're going to have this sheet, and we are going to use this to kind of read through and just refresh our memory about a valence electron. So let me read it for you here. The number of electrons in the last energy level in an element is known as a valence electron. So what I want you to do, I'm going to get my marked up copy. I want you to take or highlight that sentence. The number of electrons in the last energy level, and then highlight the word valence electron. Valence electrons are very important when trying to decide if determine if an element will react with other elements to form compounds. So I want you to highlight the word react and to form compounds. To determine the number of valence electrons, you must count the number of electrons in the last energy level. Highlight, count the number of electrons in the last energy level. Remember, the first energy level can have up to 2 electrons. The second energy level can have up to 8 electrons. And the third energy level can have up to 18 electrons. Why are valence electrons important? When the outermost energy level of an atom contains the maximum number of electrons, the level is full or complete. Atoms that have complete or filled energy levels are very stable. So this is going to be important today. So I want you to, atoms that have complete filled outermost energy levels are stable. They usually do not combine with other atoms to form compounds. So usually do not combine. They do not form chemical bonds. Elements that do not have filled energy levels will react with other elements. The fewer the number of valence electrons, the more reactive the element will be. So the fewer number of valence electrons, the more reactive the element will be. Now, what the heck does this mean? Well, let's look at it. So the other day when we colored our periodic table and we marked it up, we did mark on there most reactive and least reactive. And let's look at that. So here's our periodic table from the other day. Let me zoom back out. And we have labeled this side not reactive because it had 8 valence electrons, and we said that was full because the outermost energy level could have 8. Now, when it's full, it can't take anymore. It doesn't want to adopt or steal anything. So we call that stable or not reactive. Now, these elements over here, when we start losing electrons, become reactive. Now remember, we said the halogens were super reactive because they have 7 and they want 8. So they want to go steal from another element to combine to create a compound. So with 7, we need 8. We've got to take from an element that has 1 because 7 plus 1 would give you 8, and that would make that element full. So the halogens right here, group 17, are going to want to combine with something from group 1. They want to steal those electrons. They can also steal from group 11. Because remember, if we cover up that, We have 1. And as we come back towards the center of the periodic table, our reactivity lessens, meaning they're going to become more of a stable looking element, where these out here are going to be super reactive. And the reason we say they're more stable is they need more valence electrons, where this one only needs 1, so it's going to do all it can to get that 1. Now, anything from group 6 needs 8, which means it can take 2 from group 1 or 11, or it can take from group 2 or group 12 to make 8, because 6 plus 2 gives you 8. So valence electrons are super important. They determine what we said was reactivity. Now, periodic tables that we sometimes get in class or in lessons aren't all marked up like ours. So you just have to remember that these numbers up at the top are group numbers, and they're valence electrons, the outermost energy level. So, for instance, hydrogen has 1 valence electron. This column of beryllium, the alkaline earth, have 2 valence electrons. Now, we skip the middle, only because when you get to high school, you're going to use that one more often, but the valence electron rule kind of not messes up, but becomes different right here for 8, 9, and 10. And you'll learn more about that later. So we usually jump right on over here because we're only really worried about this part of the periodic table this year. And we look here, we have group 13. So remember, cover the 1. And 13 means we have 3 valence electrons in our outer energy level. 14 means we have 4. 15 means we have 5, and so on. Let's look back at our sheet that says what are valence electrons. So we've already highlighted, or you have, and I've highlighted my other one, but I'm not going to write on this copy right here. So let's look at the questions. It says, look at the model of hydrogen. This is hydrogen. How many energy levels does it have? Now this model looks a little bit different than what we're used to. We usually put our electrons on the line. They've kind of got this highlighted area here. So this is our energy level. So it has 1 energy level. How many electrons are in that energy level? Well, our minus sign tells us electrons, so we have 1. Now, please remember, the first energy level can have up to 2 electrons. So we have 1. We could have up to 2. So the question says, how many more electrons could go in this level? We have 1. We need to make it, or could make it 2. So we could put 1 more in that first energy level. This is boron. Let's look at boron. It has energy level 1 right here and energy level 2 darker out here. So it has 2 energy levels. Now this one says how many electrons are in the last level. Those are our valence electrons. So last level. That means the darker outside. And we have 1, 2, 3. So we have 3 valence electrons. And then this one, how many more electrons could go in that energy level? Now remember, it can go up to 8. So if we have 3 so far, and it can go up to 8, then we need to do 8 minus 3, and that's going to give us 5. So it could have 5 more in that possible outside. Here's silicone. How many energy levels are we looking at here? We have 1, 2, 3. We have 3 energy levels. How many electrons are in the last level? So let's look at the outside. We have 1, 2, followed around, 3, 4, and let's make sure we don't have any more. We don't. So we have 4 in our last energy level. Now, How many more could go here? So remember, the inside is 2, the second level is 8, and the third level can go up to 18. So we could have 18, but we only have 4. So 18 minus 4 gives you 14. Let's look at neon. Neon has 1 energy level, 2 energy levels. Our electrons in our outside are 2, 4, 6, 8. We have 8 valence electrons. How many more could go in this outer level? Remember, it's 2 and then 8. Can we put any more here? No. So 0 is our number. Now, I'm going to go back to my copy I've been highlighting on here. It says, so neon is a stable element. It does not combine with any other element to form a compound. Its family is known as the noble gases, and none of them react with other elements to form compounds. So let's highlight neon is a stable element. And the reason neon is stable is right here. We cannot add any more valence electrons to that outer level that it has. So it's happy, it's full, it's stable. Okay, let's go back here. So let's answer these questions about sulfur. Sulfur, how many energy levels does it have? So I want you to look at this one on your own. I'm going to give you a second. It should have 3. How many electrons are in the last level? That's valence electrons, outer electrons. We have 2, 4, 6. So we have 6 valence electrons. How many more could go in this level? Remember the rules. 2, second level 8, third level could have up to 18, but we only have 6, so 6 taken away from 18 gives you 12. Now this says, this means that sulfur can combine with up to 2 other elements, so sulfur is more reactive than neon. Now, the reason it says up to 2 other is because the outer energy level is not full. So what determines the reactivity of an element? Valence electrons determine reactivity. Valence electrons. So one more time. A valence electron are the electrons on the outer last energy level. Our periodic table helps us like a cheat sheet. The group number tells us valence electrons. Just remember, when you get over here, the group number that says 13, 14, 15, 16, and so on, you've got to take away the 1. So group number 13 has 3 valence electrons. 14 has 4 valence electrons, and so forth. Noble gases, not reactive. Fluorine or halogen group, super reactive. They have 7, they want 8. So it's going to be more reactive. And the other most reactive group, group 1, the alkali metals. All right.